In recent months, a growing debate has emerged in the scientific community about an object known as 3I Atlas, an interstellar visitor currently moving through our solar system. Harvard astrophysicist Avi Loeb has suggested that this object may not be a typical comet or a frozen rock from another star system, but could instead represent a form of advanced technology. While this is an extraordinary claim, he and other scientists acknowledge that extraordinary evidence would be needed to confirm it. Still, each new measurement of Atlas seems to change the story, and researchers are watching closely as fresh data arrives. When it was first detected, Atlas appeared as a faint, dim object no brighter than a background star. Discovered on July 1st, its early trajectory suggested a routine passage through the inner solar system. Astronomers believed it would make a safe, distant flyby of Mars. Interesting, yes, but not cause for alarm. Over time, however, calculations from Harvard, NASA's Jet Propulsion Laboratory, and other research teams began to show something unusual. The object's motion did not quite match what one would expect from a simple rock or comet. Its trajectory seemed unusually precise, and its path tightly controlled. New projections even raised the possibility, though still uncertain, that Atlas might pass much closer to Mars than initially believed. Atlas is traveling at an extraordinary speed of nearly 87 kilometers per second relative to the Sun. At this velocity, it could cross the distance between the Earth and the Moon in less than 80 minutes. This means that while observers on Earth go about daily activities, Atlas is moving hundreds of thousands of kilometers through space. Its path is constantly influenced by the gravitational pull of the Sun, Jupiter, and Mars. Even micrometer per second changes accumulate into major shifts across millions of kilometers. This sensitivity is one of the reasons researchers are working to refine its projected trajectory as it nears Mars. Observations by NASA's Mars Reconnaissance Orbiter have revealed striking changes in Atlas's appearance. Its coma, the hazy envelope of gas and dust surrounding its nucleus, has doubled in brightness since August. Astronomers have also detected ultraviolet spikes, short bursts of high-energy radiation, emanating from the object in patterns that have not been observed before. Measurements of carbon dioxide emissions show outgassing at rates far higher than those recorded from any known comet within the solar system. Instead of stabilizing as it approaches the Sun, Atlas appears to be accelerating. Current trajectory analysis places its closest approach at around 1.95 million kilometers from Mars on September 26, 2020. In astronomical terms, this is an extremely small margin, often described as a cosmic hair's breadth. Mars's gravity could influence Atlas enough to bring it closer still. Researchers caution that a relatively small additional velocity on the order of 10 kilometers per second could change its path from a near miss to a direct impact. For comparison, that is only a fraction of the thrust needed by large human spacecraft to leave Earth's atmosphere. Spectroscopic studies from Gemini South Observatory in Chile have added further intrigue. These observations show that Atlas does not vent gas randomly as comets typically do when sunlight hits fresh ice. Instead, every 17 minutes it appears to release a pulse of gas with remarkable regularity. This behavior has been sustained for days at a time. In nature, cometary jets are chaotic and unpredictable, triggered by surface heating. By contrast, Atlas's pulses seem coordinated. Some researchers have noted that the pattern resembles the firing of thrusters on a spacecraft. If this behavior continues, models suggest Atlas could bring itself to within 50 kilometers of Mars, closer than some of the planet's small moons. At such a distance, a single strong burst of activity could potentially push it into a collision. The potential consequences of an impact are considerable. Atlas is estimated to have a mass of roughly 10 billion tons, with a metallic core that might measure hundreds of meters across. A strike on Mars could release energy equivalent to millions of megatons of TNT, thousands of times more powerful than the largest nuclear devices ever tested on Earth. Such an impact could create a crater tens of kilometers wide and several kilometers deep, sending debris into orbit around Mars, and even into interplanetary space. Mars is not an empty world. Over decades, it has become home to a network of human-made instruments and spacecraft, including the Perseverance rover, the Mars Reconnaissance Orbiter itself, and other missions conducting climate studies, geological surveys, and life detection experiments. A significant impact near or on the planet could damage or destroy some of these assets, representing a major setback for planetary science. Behind the scenes, according to unconfirmed reports, space agencies have begun taking precautions. NASA is said to be using the Mars Reconnaissance Orbiter as a forward observation platform, while large radio antennas such as those at Goldstone are being directed to bounce radar signals off Atlas's core. Echoes received so far reportedly show unusually sharp, metallic reflections rather than the softer returns expected from ice and dust. If these early reports are confirmed, Atlas may contain an artificial interior shielded by a layer of ice and rock. Avi Loeb and his colleagues have speculated that Atlas might be a directed messenger, using controlled gas pulses to steer its path through the solar system in much the same way spacecraft use thrusters. Adding to the speculation, the European Space Agency's Mars Express orbiter recently photographed 3 faint glints above Mars. These objects, arranged in a triangular formation, appeared on consecutive orbits. Initially dismissed as cosmic rays striking the detector, some scientists are now considering whether they could represent small probes released by Atlas during an earlier pass. If true, this would be the first direct evidence of interstellar technology entering our solar system. However, such claims remain unverified and require rigorous confirmation. The time frame for action and observation is short. Between September 19th and 30th, Atlas is expected to make its final trajectory adjustments. At that point, it will be moving at around 57 kilometers per second relative to Mars. Even a glancing collision at that speed could vaporize large volumes of rock and release enough dust to create a visible veil across parts of the solar system. Critics argue that no natural comet could change its course by 10 kilometers per second using sublimation alone. The energy required for such maneuvers would exceed known natural processes. Yet that is what the current trajectory models imply. Amateur astronomers have also reported unusual visual features. Photographs show Atlas's tail splitting into 3 glowing streams that pulse with a greenish light reminiscent of auroras. These streams appear to point towards Mars, though the planet remains far away. While these observations may have ordinary explanations, they have fueled public interest in the object. Models suggest that if Atlas were to impact Mars, some fragments of debris could eventually cross Earth's orbit within a decade. Although no evidence suggests those fragments would pose a threat, scientists note that any contamination, if Atlas carries complex materials or even engineered particles, could spread beyond Mars itself. Space agencies around the world are taking notice. According to multiple reports, Roscosmos, the China National Space Administration, and Japan's JAXA have quietly formed emergency working groups to discuss planetary defense scenarios. This is the first time such conversations have been held about an interstellar object. Whether to attempt an interception or even destruction of the body remains an open and highly controversial question. As September approaches, all major observatories, including Hubble, the James Webb Space Telescope, and the largest ground-based telescopes, are preparing to focus on Atlas. The coming weeks will be critical. If the object's pulses continue and its trajectory tightens, Mars could witness an impact on a scale not seen since the heavy bombardment period 4 billion years ago. For scientists, it would be an unprecedented opportunity to study an interstellar object in extreme conditions. For humanity, it could present profound challenges. NASA and other agencies continue to issue calm, carefully worded public statements and routine images. Yet the scientific community understands the stakes. Whether Atlas is ultimately confirmed as a natural comet behaving in an unusual way or something more extraordinary, its passage through our solar system is already rewriting assumptions about what can travel between the stars. As Atlas threads its way past Mars this September, it will provide answers to some questions and raise new ones. Is it simply an ancient piece of ice and rock drifting through space, or something far more complex, perhaps a probe from another civilization, operating on autopilot or following a long-planned course? At present, no one can say. But one point is clear: the old view of Atlas as a passive comet no longer fits the data we have. In the coming weeks, humanity will watch as this visitor from the stars approaches Mars. With each greenish pulse of its tail and each subtle shift in its trajectory, astronomers will collect more information. Whether the outcome is a near miss, enzymatic impact, or a revelation about extraterrestrial technology, the results will have lasting implications for our understanding of whose Earth we live.